All right, so triangle midsegment. What we have here is a triangle that has two different midpoints on its sides. So we see the tick marks here that AD is congruent with DB, and we also have separate tick marks here to say that BE is congruent with EC, where D and E are the midpoints. I do want you guys to notice that there's one tick mark on B and D, B, D, and A, and there's two tick marks on B, E, and C. So in other words, that could be that this is 5 and this is 7. They are not congruent, but they are congruent down here. Some of you guys may think that's kind of self-explanatory. I just want to make sure. So a mid-segment of a triangle is a segment connecting the midpoints of two sides. So in other words, this DE is our mid-segment right here. It connects the two midpoints. So if a segment joins the midpoints of the two sides of a triangle, in other words, if it's a mid-segment, then the segment is parallel to the third side. So if you notice, DE is parallel to AC. It's parallel to this third side. And we also know that it is half as long. So in other words, if DE was 10, that means that AC would be 20. It's half as long, okay? So using the diagram above, the two things that we know is that DE is parallel to AC, and you can just put your two lines like that for parallel. And then we know that DE is half as long as AC. So there's two ways we can write this. We could say 1/2 times AC will equal DE. Or we could say that 2 times DE will equal AC. So be very careful with how you denote that. Make sure you're multiplying the mid-segment by 2 and taking the third side and taking half of it. All right, so for number 1, identify all pairs of parallel segments. So we will look at this first midpoint, or mid-segment, XW, and we know that XW will be parallel to that third side, the side that it does not touch, and that will be RS. So XW is parallel to RS. Then we would have XY, and XY would be parallel to QS. And lastly, we have WY, and WY will be parallel to QR. Number 2 is the exact same thing. For number 3, if those are midpoints, so we have mid-segments, and PR is 46, so this whole thing is 46. PQ is 40, so that whole thing is 40. And LN is 17. This little part right here is 17. Then find each measure. So we know, first off, that N and L are midpoints. So if N is a midpoint, that means PN has to be 23 and NR has to be 23 because it's halfway of that 46. So the same thing with L. PL will be 20, LQ will be 20. And then lastly, to find this other side, LN we know is half of QR. So that means QR, the whole thing, has to be 34. It's 17 doubled. So that means that QM and MR are 17. So then also we need to find these other mid-segments. So LM would be 23. It would be half of the third side PR. And then we also have 20 for NM. So that's all of our figures, and now we just have to kind of plug them in there. So LM is 23, MN is 20, QR is 34, and MR is 17. All right, for number 5, it just says find the value of X. So all we have to do is take this mid-segment, which we know if we double that mid-segment, it will be equal to that third side. So that'll be 14x equals 17x minus 18. We will subtract and get a negative 3x over here, and x will equal a positive 6. It didn't ask us to plug in for anything. All we need is to find x. So we're good. This is just testing your knowledge to make sure that you understand the difference between multiplying by 2 and dividing by 2 and when you need to do which one. So some people would say, hey, why don't we divide the side by 2 to set it equal to the midsegment and make it a little smaller and use smaller numbers? I agree with that only in certain cases. Only when you can take that third side and take all of its expressions, all of its terms, and if they're divisible by 2. So if you see here, 11x minus 25, neither one of those are divisible by 2. It'd be a lot easier to double 4x plus 1. Same thing over here, 17. It's odd, so I'm not going to be able to divide it by 2. Same thing for 19 there. Same thing for 15 or for 23 there. So it's in all of these that could work, but I would suggest doing it this way and doubling the midsegment just because those are odd. If they were even, then absolutely take half of both of them. It would make things so much easier. All right, so that'll be 3x, add, and x will equal 9. Now they asked us to find DE, so we need to take that 9 and plug it back in right here. 4 times 9 plus 1 will give us 37. RT is the same sort of thing. So for number 9, if MN, NO, and MO are all midsegments, find the perimeter. Okay, so we know that NO right here is half of KJ, so that will be 84. And then we know that MN is half of JL, so that will be 98. But then for KL and MO, they gave us an expression, so we need to double 6x minus 1 and set that equal to 13x minus 10, 12x minus 2, and x will equal 8. So then we take that 8 and we only need to plug it into KL. We don't care about the other ones, right? So we'll plug in 13 times 8 minus 10. 13 times 8 will be 104, minus 8 will be 94. So we take 84 and 94 and 98 and add all those up. And that will be 276. All right. So that is our perimeter. For number 10, I'm going to do 10 and 11 with you guys because these are where people really start to get a little confused. So to find the measure of each angle, first off, now we're talking about angles, we're not talking about distances. So what did we learn in the very beginning that would help us with angles? We learned that the segment is parallel to the third side. So we know that this line right here, this midsegment, is parallel to our third side. Now, this is going back and using parallel lines and transversals again. Okay, so we have two parallel lines, and the sides of the triangles are actually our transversals. So if you notice, now you can see that 1 and 2 are corresponding angles. They're going to be equal to each other, right? Same thing over here with this transversal and 4 and 59. They're going to be the same. Again, corresponding angles are the same places in the intersection. So for 4 and 59, they're both in the top right of that intersection. For 1 and 2, they're both in the bottom of that intersection. All right, so let me erase those. But we know that 4 and 59 are going to be the same. So we can put 59 degrees right there. And then we know that 59 degrees and angle 5 add up to 180. That's a linear pair, right? They make a line. So 180 minus 59 would be 121. And that would be angle 5, 121. Now, I do want you to understand that 121 and 127 are not the same, right? These are two completely different transversals. So that they aren't going to be the same. 59 and angle 2, 59 and angle 1 are not going to be the same. For angle 2, we know that's a linear pair with 127. So we do 180 minus 127, and that would be 53. and that would give us angle 2, which we know is also equal to angle 1. That's going to be 53 degrees because of those corresponding angles. And lastly, we have 53, 59, and angle 3. So those make a triangle, and we know that all the angles in a triangle will add up to 180. So we do 59 plus 53 minus 180, and that will give us 68 degrees. So that last one is 68 degrees right there. All right, so I'll do the same thing with 11. So we have 118 and 1 right here is an easy one that I see off the bat. 180 minus 118 would give us 62. So angle 1 is 62 degrees. So if these two lines are parallel, and this is our transversal, we know that 1 and 5 are congruent. So if 1 is 62 degrees, we know that 5 also has to be 62 degrees. All right? Now, we don't know anything about 2, 3, and 4, okay? And be very wary of not going this way. You cannot do that. You can only go from one intersection to another intersection on the same transversal, okay? So don't jump to a different transversal. But we do have 95 and 62. Okay, so 95 and 62 will be 157, and then we subtract that from 180 to get this other angle right here. So that angle 2 will be 23 degrees, which would be the same as angle 4 because they're corresponding. And then 2 and 3 add up to 180, so that will be 157. If you also notice, angle 3 is kind of an exterior angle theorem with 95 and 62 and this exterior angle because this side is extended on. We did that last week. But if you don't know that, that's okay too. All right, so for number 12, we see that, again, we're talking about angles. We have this parallel line, and and this transversal. So I think it really helps you visually if you just write out and extend those lines and write out your transversal. Now we can see that both of these angles are in the top left. So they're corresponding, so we know these angles will be congruent. And x will equal 5. The same exact thing will be for 14. They are corresponding, and they will be congruent. All right, for number 13, we have, again, these two parallel lines, the mid-segment and the third side. And then we also have our transversal cutting across it. So now you notice that these lines, or these angles, are both on the same side of the transversal, and they are interior. So this is same side interior, or also called consecutive interior. And what we know about those is they are supplementary. They add to 180. So we will do 5x plus 2 plus 11x minus 30 and set that equal to 180. 16x minus 28. And that will be 208. So 16, I think that's going to be 13. 208 divided by 16, yep, 13. And again, they're just asking for the value of x there. Now, if you're doing 14 to 15, this is also same side interior for 15. But note that they're not asking you to solve for x. Now they're asking you to plug back in for the angle. So all you do is find x and then plug that angle back in. Triangle mid-segments are really big. We use them a lot in Math 3. So make sure that you guys know this stuff. And if you got any